Alright, so when I first started teaching Organic 2 and I taught thermodynamic kinetic products, I taught them for a long time, just thermodynamic and kinetic products. Until one semester I had a student ask me, well, I've also heard it called 1214 edition, and it was one of those like, that's really how I should have been teaching it the whole time. So, if you find old videos on my channel about thermodynamic and kinetic products, that's where they come from. Now, I'm still going to talk about thermodynamic and kinetic, but we're also going to approach it from the 1214 edition. And the thing about thermodynamic and kinetic, the 12, the 14 is the easiest to see, but we do need to talk about why they are called what they are. So let's say I have conjugated diene. And the big thing here is that we're going to start out with just these symmetric conjugated dienes. If I add something to the double bond, HX, if I number the carbons, 1, 2, 3, 4, I can get 1,2 addition, or I can get 1,4 addition. And the thing with the 1214 addition, the 1 is where we're going to add the hydrogen. So we add hydrogen here for the 1 carbon. The 2 or the 4 refers to where our X is. So this can be a chlorine, bromine, it could be an H2SO4. It's whatever we add, or HSO4, it's whatever we add when we add to the double bonds. And we can either add it on the 2nd carbon, or we can add it on the 4th carbon. This first one here is called the kinetic product. So the 1,2 addition here is kinetic, and the kinetic just simply refers to speed. We can quickly, if we just added the HX, let it react and immediately isolated what came off, we would get the 1,2 product. Now, annoyingly, the 1,4 product is called the thermodynamic product. So why is this annoying? Thermodynamic does not mean the same thing in chemistry that it does in engineering. So when we say a thermodynamic product, and honestly this is what it's going to be referred to most often, a thermodynamic product is the most stable product. So at high temperatures, which eliminates all activation barriers effectively, we should produce the most stable compound, and we would call that the thermodynamic. Well, the misnomer here in chemistry, and unfortunately it's what we're stuck with here, is that we're going to call it the thermodynamic because it's what's accessible at high temperatures. That does not mean it is the most stable, it just means that we have to go to high temperatures. So at high temperatures we form the 1,4 product in addition to the 1,2 product, and their ratios depend on their relative stabilities. So what we're going to talk about in the next few videos is actually breaking down the mechanism between this 1,2 and 1,4 addition, and why we get 1,2 versus 1,4, and why the X always has to be added to the 2 or 4 position. And we're going to start easy. We're going to start with a symmetric diene, and then we're going to start seeing how this gets a lot more complicated when you get to asymmetric dienes.